personally, I don't like factoring quadratics when the leading coefficient is negative. It's doable, it's actually not that much harder, but it's just a personal thing. I find it much easier to factor if things are positive, so I'm going to just check here. Can I do this and factor it? I would need the 2 out, so my outside is 4, inside is 1. If they're both negative, I make a negative 5, and I double check that. That all multiplies out nicely. So after factoring, my non-permissible value is that x can't equal 1, and it doesn't cancel out. So I know that I'm going to have a vertical asymptote at x equals 1. Nothing canceled out. This is one where the degree is bigger in your numerator. This is our example where we get an oblique asymptote. And we find our oblique asymptote by doing synthetic division. What was our original equation? -2, +5, -2, and we're dividing by x minus 1, so we put a 1 out in front. Bring the 2 down, multiply, add, multiply, add. Right, this is your remainder. You can ignore the remainder, and your oblique asymptote is at y equals -2x plus 3. So I'm going to start my graph here on the side. I know that I have a vertical asymptote at x equals 1. And I have an oblique asymptote at -2x plus 3, which means I have a y-intercept of 3, a slope of -2, down 2 over 1, down 2 over 1. There's my oblique asymptote. Now we find our intercepts and see if we have enough points. Y-intercept, plug in 0 for x. I always like to go back to my original equation, -2 over -1. 0, 2. And x-intercepts, plug in 0 for y. I find looking at the numerator of your factored version is going to be the easiest way to find your x-intercepts. What would make your numerator 0? Well, +1/2 would make the first factor 0, and +2 would make the second factor 0. So I go and I label those points. 2, 0, and 1/2, 0. Especially with a steep line, you might think your graph is separated into 3 sections, but it's only your vertical asymptote that separates things into sections. Do we have something here in this first section? Do we have a point in this second section? Or do we need more nice points? Well, in section 1, I have these 2 points. And I have enough to graph those. In section 2, I have a point. I find in particular, be careful, because I find this happens, I'm going to show it in yellow. Somehow with the oblique asymptotes, it's so tempting to turn it away at the end. Then you're going to get an E10 because your asymptote, you always need to get closer to your asymptotes. That yellow is not the best to show it. Here, I'll make the mistake in purple. It's so, I don't know, like, it's like you have to have willpower not to turn it away from the asymptote on an oblique one. I'm not sure why it happens that way. Maybe because you're so used to going towards horizontal ones, you want to flatten out? I'm not sure. But it's really tempting not to go towards your asymptote with oblique ones. A pattern you might start to notice with oblique asymptotes is that you're either going to have your graph like this one, here and here, or if you had your graph in here, the other part would have to be in there. It's sort of opposite that way. That's a pattern that you'll start to see with the oblique asymptote graphs. Okay. For this one, circle question number 5.